All around us, we see a great diversity of living things, from the microscopic to gigantic, from the simple to the complex, from bright colors to dull ones. One of the most intriguing things we see in nature is pattern. Patterns in nature are visible regularities of form found in natural world. These patterns record in different contexts and can sometimes be modeled mathematically. So in this video, we will talk about patterns in nature, together with my groupmates, Juneza Labajo, Jilanime Aguilar, and your speaker, David Gamboa. There are three kinds of symmetry: the reflection symmetry, radial symmetry, and the translation symmetry. Reflection symmetry. Reflection symmetry is a type of symmetry which is with respect to reflections. A reflection symmetry is also known as line symmetry or mirror symmetry. It is the mirror effect, or when one object is reflected or flipped across a plane to create an image of itself.
Radial symmetry. Radial symmetry is also known as rotation symmetry. It is when one object is rotated in a certain directions around a point. An example of radial symmetry is wheel, because when the wheel is spinning, it's exactly the same rotated on its own axis.
Translation symmetry. Translation symmetry, such as repeating tiles or wallpaper patterns, means that a particular translation on an object to another location does not change its pattern in a specified distance without any rotation or reflection. Spiral. A spiral is a curved pattern that focuses on a center point and a series of circular shapes that revolve around it. As an example of spiral is mollusk shells and snail shells. Meanders. A meanders is one of a series of regular sinuous curves, bends, loops, turns, or windings in a channel of a river, streams, or other watercourse. It is produced by a stream or river swinging from side to side as it flows across its floodplain or shifts its channel within a valley.
Waves. A drop of water in the faucet is an example of a wave because of its vibrational frequency. When we say a wave, it is a phenomenon created within a medium when the vibrational frequency, wavelength, and amplitudes occur. Example of this is the sea. You can see the sea, there is a waves, and a guitar is also part of a waves because it produces sounds. Foams or bubbles. A foam is a substance made up of bubbles packed closely together, or a substance made by trapping air or gas bubbles inside a solid or liquid. So when a foam forms, there may be some number of large bubbles interspersed with smaller bubbles in the gaps. One of the example is a soap bubbles. When it tends to be very large, you might call it a froth.
Tessellation. Tessellation is an arrangement of shapes closely fitted together, especially of polygons in a repeated pattern without gaps or overlapping. As an best example of this is floor tiles and pineapple, because the shapes fitted together repeatedly without gaps or overlapping. Fractures and cracks. Fractures occurs when the applied stress is sufficient to break the atomic bonds of the solid. A separation of an object into two or more pieces under stress, while cracks is a line on a surface of something along which it has split with breaking into separate parts.
Spots and stripes. Spots and stripes is made by series of band or strips that differs in color or tone from an adjacent area or in a circle form. We can see this in nature, man-made, or in animals. There are many spots and stripes that we can see around, like the animals. Example for these are giraffe. It has made up of spot of its body and also the piglet. Fractals. A fractal is a never-ending pattern. It is infinitely complex patterns that are self-similar across different scales. Example are the branches of trees, leaves, and the petals of flowers because it is created by repeating a simple process over and over in an ongoing feedback loop.
Affine transformation. When we say affine transformation is a linear mapping method that preserves points and straight lines and planes. The processes involved in affine transformations are rotation, reflection, and scaling. So, as an example of affine transformation is this plant because of the scale and also the cactus.